Hey guys! Okay, so this is part 2 of the test 2 review. We just finished number 9, and number 9, the directions said some hoopla about no decimals, reduce, ration needed. Yeah. Okay, for this problem, I'm going to fix the directions so that they just say round to a whole number. Yeah. So if you did this a different way with values from the unit circle or special art triangles, you probably got the same answer as me. It's just that I put it in a calculator and rounded it to the whole number. Okay, but I think this calculator way will be easier for you on the day of the test. So if you want to do it this calculator way, it might be better on the day of the test. Okay, number 10 says using the unit circle, find the following angle. No decimals, blah, 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 blah. Okay. So secant inverse means we're supposed to find the angle. And I know that I'm supposed to find the angle because it says it in the directions. Find the angle. Okay. So first let's figure out what secant is. Secant is the reciprocal of who? Cosine? So secant is cosine upside down. On the circle, what is cosine? Cosine is x on the circle. So let's find the angle that when I flip its x value from the circle, I get this nasty thing of 2 square root of 3 over 3. Okay, I cannot find my unit circle. Gosh darn it. Okay, so on the unit circle, we have points of like 1/2. I think we got a square root of 3 over 2. There's also some square root of 2 over 2s. There's some 1s and some 0s, something like that. Those are pretty much the numbers for our points of the unit circle. Which one of those points, or which one of those numbers, could flip upside down to give me this secant 2 square root of 3 over 3? Well, I'm not going to be able to flip this 1/2 and get this because there's no 3 in the 1/2. I can't flip this square root of 2 over 2 and get this because there's no 3 there. Definitely can't flip the 1 and the 0. So that must mean I'm supposed to be flipping a square root of 3 over 2. Let's see what happens if I flip that. Let's see if I get this 2 square root of 3 over 3. Okay. So I flip the x value, then I multiply by the square root, and you get 2 square root of 3 over 3. That's not the answer. That is the correct x value that I need to look at on my unit circle to give me the correct angle. So I'm going to look on the unit circle for when the x value is square root of 3 over 2. And it should be right here at pi over 6, or perhaps at 11 pi over 6. Yeah. Okay. And you can just write one of these. So it just says find the, that means 1. So if you write just this first angle of pi over 6, I'm good. If you write the second of 11 pi over 6, I'm good. If you write both, I'm good. If you write negative 11 or negative pi over 6 or negative 11 pi over 6, I'm good because those technically land on this spot also. Okay, so the point is you only need one answer for each of these. Let's look at the second sucker. It says tan inverse. Well, darn it, we need to remember that tan is not x or y. Tan from the circle is y over x. So tan is y over x. So let's think back. Out of all these options up above of the numbers that represent the points around the circle, out of all these numbers, which ones do you think we could divide to get a square root of 3? Well, I probably can't divide by 0. Okay, there's no plain square root of 3 on my circle, so I can't divide by 1. This square root of 3 does not have 2's in it, so square root of 2 over 2 is out. So that means I must be dividing a combination of the 1/2 and the square root of 3 over 2. Okay, so let's try just 1/2 over square root of 3 over 2. Let's see if that's the right combination. You might already know it's not. The 2's cancel, and you get 1 over square root 3, but then you can't have a square root in the bottom, so you multiply, and you get square root of 3 over 3. Either way, that's not the right combination we need. I think it's the right combination for this very last sucker. Let me just... Okay, let me remember that for later. But for this problem we were working on, it's not the right combination of y over x. So let's try a different one. Let's try y over x to be the same numbers, but different combination. The 3 on top, the 1/2 on bottom. And from there, you see that the 2's cancel. You get square root of 3 over 1, and that divides out to be square root of 3. That's what we need, only we need it negative. Okay, let's think about this. What kind of symbols divide out to make the negative square root of 3 that we need? What kind of symbols divide to make a negative? Different symbols. So we need to be looking for the y value of a square root of 3 over 2, an x value of 1/2, but they have different signs, like plus minus. That's what I mean when I say different signs, plus minus. Okay, so let's look on our circle for when the y value is square root of 3 over 2. Oh, I can't look in this top right quadrant because all those signs are positive. Let's go to this top left quadrant. Let's see. Y is square root of 3 over 2. It looks like it's about 120 degrees, or 2 pi over 3. So that's when y is square root of 3 over 2. X is some kind of 1/2, and the signs are different. Like one's a plus and one's a minus. So definitely 2 pi over 3 is an answer that I would take. I think another spot is maybe this spot right here, where the y value is negative square root of 3 over 2, and the x value is 1/2. Those symbols are different. We got a plus and a minus. So I'm going to also use that one, 5 pi over 3. And like I said earlier, you can do one or the other. I don't mind. You could put 12 angles on here, and as long as one of them is right, that's the only one I'm looking at. Alright, let's look at cosine inverse. Cosine inverse, this one's a trick. Cosine is just x. So there's no reciprocal. So let's find when x is 1/2. For sure here at pi over 3, 60 degrees, and also here. This is when x is positive 1/2 at 5 pi over 3. So we have pi over 3 and 5 pi over 3. And again, I don't care whether you put the pi over 3 or the 5 pi over 3, I'm desperate. If you put, I think technically even negative pi over 3, you could have put, and I would have counted that right. Okay, lastly, tan inverse. Well, we kind of already did this accidentally. We saw that the way to get square root of 3 over 3 is to have a y value of 1/2 and an x value of square root 3 over 2. So let's find when a y value is 1/2. Here, right here. Okay, so that's pi over 6. When the y value is 1/2, and the x value is square root of 3 over 2. So we need that y over x. We accidentally already did it, but I'm still going to write it down just in case you want it. So the y has to be 1/2. The x has to be the thing with the square root. When you multiply by a square root, it puts it in the top, so we get square root of 3 over plain old 3. And heck fire, that's what we need. So now let's ask ourselves, what kinds of symbols, like pluses and minuses, divide to become a positive? Same signs. Like we either need a plus minus or a minus minus. Okay? No. Plus plus or a minus minus. Alright, let's look. When the y is 1/2 and the x value is square root of 3 and they're both positive, pi over 6. Okay? Or let's look for a negative negative. Y value is negative 1/2, x value is negative square root of 3 over 2. So at 7 pi over 6. Hey, and I'm okay with either one of these, pi over 6 or 7 pi over 6 or I think even negative 5 pi over 6. But I just want one. If you put multiple, that's cool, but I'm just going to look for one correct to get your credit. Okay, number 11 says, using the calculator, find the following angle in degrees. Okay? Degrees means your mode is in degrees. That's what we used to say when I was a kid, when it was obvious. So anyway, let's put this in our calculator. My mode is correct. Now let's do tan inverse. You don't have to put that 0 if you don't want. Then cosine inverse. Okay. For that tangent, we get negative 15.1. But the directions, I was easy, and I said just round to a whole number. Okay, negative 15. And this is the angle in degrees. So put a degree up there. Okay, then when I do cosine, I kept getting error. That technically means undefined. Or if you want to write not possible. Or if you just put error, I'm good to go. Okay, now let's do sine inverse. (65.5-ish) rounded to the whole number is 66 and a degree. Okay, let's keep going. Number 12. Okay, first, the big parentheses tell you how to draw the triangle. And then usually we probably need to use the Pythagorean theorem, because I'm guessing a piece of the triangle is going to be missing because there's 3 sides to a triangle and this fraction only has 2 pieces. Okay, so we're going to draw a triangle, use the Pythagorean theorem, and then this secant means that's what the answer is going to be. Yeah. Okay, so first let's draw our triangle. Okay, and when I draw my triangle, I need to remember that bow tie from back in the day that I told you to draw every triangle like. Remember the bow tie or a necktie or that pasta that people eat? I've never had it. Okay, anyway, you put the theta near the center. Yeah. So for this triangle, it looks like this triangle. So put your theta at the center. Or near the bottom left. Okay. Okay, now let's see. Sine means so. And that 15 over 17 is now our opposite over our hypotenuse. So our hypotenuse is 17. The opposite of this angle is 15. Okay, so we've taken care of this sine by labeling opposite over hypotenuse. The inverse means that this 15 over 17 is not the angle. It's the sides. Okay, now we want to come up with secant. And I haven't done the Pythagorean theorem, but let's check it. Okay, secant is cosine upside down. What is cosine from a triangle? From a triangle, cosine is ka upside down. Yeah? So we need to do hypotenuse over adjacent, because that will upside down the ka, or that will reciprocal the cosine. Okay, well, I know the hypotenuse is 17, but this is where the Pythagorean theorem comes in. We need the adjacent from this triangle. Dag darn it. Let's go. A squared plus b squared equals c squared. A squared we don't know, plus 15 squared we do. It's right there. Equals c squared. That's always the hypotenuse. I think when you subtract this, I remember from class it was like 64 or something. So A is 8, and that's the adjacent. Okay, so the big parentheses with the sine inverse told us that inverse means 15 over 17 is the opposite over the hypotenuse of the angle. Now we want to find secant. We know it's hypotenuse over adjacent. Well, 17 over or adjacent is 8. Yay, that's our answer. Okay, and the direction said no decimals, check mark, reduce. We cannot do that. All right, let's keep going. Number 13, amplitude. Amplitude is the absolute value of your A. Or, if you can't remember that, it's just the positive part of the A. Okay. So, A is the number that's to the left of the sign. So, these are all your A's. 9, 1/9, -9. So, your amplitude for part A is 9. Your amplitude for part B is 1/9. Your amplitude for part C is triggery-dickory-dock. You just use the positive because of absolute value. So the amplitude for part C is 9. Okay, on the test, there's only going to be one of those. Let's go to part 14. Number 14, it says identify the phase shift. Okay, phase shift is how our graph moves left to right. It's negative C over B. And if it's negative, we go left. If it's positive, we go right. I think in class I ran out of room for that. Positive right. Okay, let's go. It says identify the phase shift and whether you go left or right. No decimals, reduce or rationalize if necessary. Okay, phase shift, negative C over B. Uh-oh, I need to figure out what my C and B are. Well, A is what's in front of the S. We don't care about him. B is what's in front of the X, my good friend 1. C is what's after the plus or the minus, but still in the parentheses. And D, well, there is no D. Okay, it would be plus or minus on the outside of the parentheses. Okay, let's go. C, negative, then pi over 8, all over 8, all over 1, because your B is 1. And then when you divide that, you just get negative pi over 8. Anything divided by 1 is just still itself. Okay, then negative means left. Okay, part B, negative C over B. C again, is the number in the parentheses after the x. B is the number to the left of the x inside the parentheses. Okay, so negative c over b is negative pi over 8 all over 2. Now we got to do keep, change, flip. Because anytime we divide with a fraction, something's going to happen. So the big bar that separates the c and b is what separates the top and bottom. So we're going to keep negative pi over 8. We're going to change the big bar to a multiply dot. We're going to change that 2 to a... who could we flip him to? He's technically on top of a 1. So let's flip it, 1/2. Okay, when we multiply left to right, we get negative pi over 16. It's negative, so it means left. Okay, last one, C. This is the awkward one. This one's awkward because the 3 pi is the B. Yeah, not just the 3 pi. So let's do negative c over b. This one's also awkward because you have a double negative. Let's see what happens. On the top, we have a negative because the c right here in the formula, it says negative. I wrote down negative. Okay. Then your actual c value is this negative pi over 8. And then your b, what was your b? Oh, 3 pi. Okay, first off, the double negative makes a plusative. Second, we're not sure if the pi's cancel. They do. Technically, they cancel. Because this 3 pi on the bottom is actually over 1. And what we learned today with the identities, we learned that pi over 8 over 3 pi over 1. We learned that if the bottoms are the same, they cancel. But we also learned that if the tops are the same, you cancel and you flip it upside down, whatever's left over. But the issue is I have a bunch of stuff left over, 8, 3, and 1. Okay, so I know I'm going to cancel the pi's, but I'm not real for sure how. So I think I'm just going to do keep, change, flip. Pi over 8 stays how it is. We change the bar to a dot. 3 pi goes to 1 over 3 pi. So the pi's cancel, huzzah! Just like we thought they were going to do earlier. But the top is now 1 and the bottom is not 8 or 3, it's both 8 times 3 or 24. This is positive, so we go right. Yeah. Alright, let's keep going. The period. Period is 2 pi over b. Okay. And where is the b at? B is on the x. Okay. So we're going to have 2 pi over, who's the b here? There has to be a number right there. 1. Yeah. Okay, so 1. And when we divide that, we just get 2 pi. Huzzah. Let's change it. Now we have 2 pi over, who's my b? It's the number on the x, 2. Well, the 2's cancel, and I just get pi. Okay, lastly, 2 pi over, what's the issue here? Am I going to do divided by 3 or 3 pi? We have to remember that 3 pi is the b. So whatever is attached to that X is the B, even if it's a symbol. Because that symbol technically means 3.14, yeah, which is a number, which is what the B is. Okay, so now the pi's cancel. Shabooey. And we get 2 over 3. That's how long the period is. And I know it's missing the pi, but it's okay. That happens. Okay, lastly are these 2 questions at the end. And remember, I told you that these would be bonus. Yeah. And they're going to be bonus because number 1, we haven't gone over word problems. Number 2, we just learned this yesterday. Number 3, it's too quick to ask you to do all this for real points. Okay, so this is bonus. All right. We already did this in class, but let's go ahead and go over it again. The questions say, how long is the respiratory cycle? Cycle is another word for period. When something cycles through, that's one period. When something has one period, it's cycled through once. So your period is 2 pi over B. Okay. It says, what is the maximum rate of air intake? We learned yesterday that maximum is the highest. So part B is asking about how high the graph is going to be. And we learned that how high is your amplitude. Okay. Then part C says graph. What interval does inhalation occur? What interval does exhalation occur? I don't think I'm saying that right. Okay, first, let's read the problem. We got a word, we got a formula. Great. It says a respiratory cycle, that means how we breathe, is defined as the beginning of one breath to the beginning of the next breath. So after you inhale and exhale, a cycle happens. It says the rate of air intake R in L per second. What? Okay. So R is L per second units. Okay. During a respiratory cycle for a physically fit male can be approximately